We live in a remarkable time. Machines are moving from the factory floor to our homes and offices. These aren't just any machines. These are robots, capable of sensing, thinking, and acting in the world. Robots are no longer science fiction. They are becoming part of our everyday lives. We see them building our cars, assisting in surgeries, and even exploring other planets. But what makes a robot tick? What are the fundamental building blocks of these incredible creations? To understand robots, we must journey into their inner workings. We must unlock the secrets of their parts. Like us, robots need to perceive the world around them. They do this with sensors, their electronic senses. Sensors give robots the ability to see, hear, touch, and even taste. Imagine a self-driving car. It uses cameras, which are visual sensors, to see the road and other cars. It might also use radar, a sensor that bounces radio waves off objects to measure distances, or consider a robot designed to explore the bottom of the ocean. This robot could use sonar, which works like radar, but with sound waves, to navigate in the dark depths. From light to sound to pressure, sensors are a robot's window to the world. Sensing the world is just the first step. Robots also need to interact with their environment. This is where actuators come in. Actuators are the muscles of a robot, allowing them to move and manipulate objects. The most common actuators are motors. Electric motors convert electrical energy into mechanical energy, making things spin or move linearly. Think of a robotic arm used in manufacturing. Electric motors power the joints of the arm, allowing it to pick up and place objects with precision. Other types of actuators include hydraulic and pneumatic systems. These use fluids like oil or air to generate movement, often for heavy-duty tasks. Sensors provide data about the world, and actuators allow for movement, but what tells the robot what to do with this information? The answer lies in the control system, the brain of a robot. The control system is like a computer program. It receives input from the sensors, processes this information, and then sends commands to the actuators. This could be as simple as a pre-programmed set of instructions. For example, a robotic vacuum cleaner might be programmed to follow a specific pattern to clean a room. More sophisticated robots use artificial intelligence to make decisions based on their surroundings. They can learn and adapt to new situations, making them more versatile and autonomous. Section 5. Powering the machine. Just like humans need energy to function, so do robots. The type of energy source a robot uses depends on its size, purpose, and operating environment. Many robots get their power from batteries. Batteries store chemical energy and convert it into electrical energy, providing a portable power source. Larger robots, like those used in factories, are often connected to a power outlet, just like our household appliances. Some robots are even designed to harness energy from their surroundings. Solar-powered robots, for example, use sunlight to generate electricity. Section 6. Putting it all together. A robot's workflow. We've explored the individual parts of a robot, but how do they work together seamlessly? Let's consider a simple example, a robot designed to pick up objects. First, sensing. The robot uses its camera, a visual sensor, to see the object. Next, processing. The control system processes the image from the camera, identifying the object's location and orientation. Then, decision-making. The control system uses its programming to determine the best way to grasp the object. After that, action. The control system sends commands to the robot's arm, which is powered by electric motors or actuators, to move towards the object. Finally, interaction. The robot's gripper, another actuator, closes around the object, picking it up. This simple example illustrates the coordinated effort of a robot's components, sensors, actuators, and control system, all working together to accomplish a task. Section 7. Robots in our lives. The parts we've discussed are not just abstract concepts, they are the building blocks of robots that are already impacting our lives in profound ways. In healthcare, surgical robots assist doctors in performing minimally invasive procedures, leading to faster recovery times and fewer complications. In manufacturing, robots work tirelessly on assembly lines, increasing productivity and improving the quality of our products. And in space exploration, robotic rovers explore the surface of Mars, sending back valuable data that expands our understanding of the universe. Section 8. The future of robots and us. As technology continues to advance, robots will become even more sophisticated and capable. We can expect to see robots taking on more complex tasks, from driving our cars to assisting with elder care. This new era of robotics presents both challenges and opportunities. It's essential for us to understand how robots work, not just engineers and scientists, but everyone. Just as we teach our children about the basics of biology or physics, we must also educate them about the fundamentals of robotics. This knowledge will empower them to navigate a future increasingly shaped by these intelligent machines. Section 9. Unlocking our robotic future. Understanding the parts of a robot is not just about satisfying our curiosity, it's about unlocking our own robotic future. When we grasp the fundamentals of how robots sense, think, and act, we can better harness their potential to address some of humanity's greatest challenges. We can design robots to perform dangerous or repetitive tasks, freeing up human workers to focus on more creative and meaningful endeavors. We can develop robots to assist people with disabilities, enhancing their independence and quality of life. The possibilities are limitless, but to realize this potential, we must first unlock the secrets of robot parts, embracing a future where humans and robots work together to build a brighter tomorrow.